Hello, this is Mr. Doty, and we're going to go for a second take on this video. First take kind of got interrupted, and that's all right. So what we're doing today is a continuation of talking about bearing, slope angle, grade, true length. Hey, that's something that we've dealt with before. So this is the third assignment on descriptive geometry, the second part. And basically, if I can find it over here, this is the problem we're working with. So we've got a line that's BC. It has a bearing of north 22 degrees west. Now, if you'll remember from the other video, if you've watched it, that I talked about bearings, and on that one we had to find the bearing, and you were already given a north arrow. Okay, so on these I have the north arrow, right? And you'll notice that it says west. So which way is west? Well, obviously west is over here, correct? And then east will be on this side. So that means that my angle is going this direction, okay? Now on this one over here, number 2, RS, this one is south 75 degrees east. So that means we're going to be going down, which is south, and we're going 75 degrees east. So we're going to measure, 0 is here on the bottom here. You know, like if we were normally, we'd say 270, right? Well, we're going to measure 75 degrees this direction because it's east. So that means I'm going to be working the problem over here, most likely. So, and the last one, obviously, is MN, and it says north 60 degrees east, which 60 degrees east will be on this side, okay? Now, the other things they gave us was it has a slope, positive 15, negative 10, positive 30. The true length is 3 inches, 4 inches, and 5 inches. Well, you'll notice that I don't have anything to start with except for these 2 points and a north arrow. Well, with that information, what can I do? Well, I've been given the bearing, so we could start with that. So I said 22 degrees west, right? Well, if I want to draw a line, and I want to draw it from this over here. Now, we need to think about where we're measuring from, right? So I'm measuring off of north, which is technically at 90 degrees, right? So 90 degrees plus 22 degrees gives us what? Would that be 112? If I did my math in my head right, it is. So what I'm going to do is I'm actually going to hit my tab key. Now there's a lot of ways you can draw lines. I'm not going to tell you how to draw lines. You can use the @ symbol, whatever. I'm just going to hit tab, and I'm going to go over there. I'm going to hit 112. Alright, so if I did my job correctly, now you'll notice that I wasn't worried how long this line is, because right now I only have the bearing. I don't have any other ideas. So let's go up here to angular, and let's see if I have the bearing correct. Well, as luck would have it, I'm actually batting 1,000 so far. We're doing okay. So that would be 22 degrees going north on the west side. Okay, there we go. So I know I have my line going this way. So what's the next thing I need to do? Well, I cannot tell what the slope is here because, and I can't tell what the true length of it is here because it's not parallel to my fold line, right? So what I need to do is I need to create a fold line. So I'm going to copy this one, and I'm going to copy it up this direction just because it might be easier to work over here, and we'll go from there. Now I cheat, so what I do is I use under the parametric, which I have a pull down, you know, I have this turned on, my toolbar. So you go to parametric, geometric constraints, I want parallel, And what it is I want the line parallel with this guy, right? There it is. Alright, so I'm going to take this line, I'm going to move him, and scoot him up here where I can see. Alright, so this is parallel with this, therefore this view up here is going to be true length. So how do we draw our lines up to there? Well, I told you in the other video I like to use the ray command, and the reason I use the ray command is because it's a lot easier to draw a perpendicular line through a point like so, and then I don't have to worry about how far out it is over here. And then I'm just going to go to copy, and I'm going to copy, if I can get it to cooperate, I'll copy and stick it up there like so. Alright, so next thing, well, I know that A is this far off of the line, so I can locate this point at least, right? Well, let's think about that. How do we do that? Let's go to offset, and I'm going to try to find the center of this lovely thing here. Maybe I should try a center, and then it's only going to look for the center, and I'll take this distance and offset it up that direction. Okay? Alright, so I have my point A, so I could just take this and go copy, and we'll just go from there up to there, and there's point A. Alright, so what was the next thing on there? The next part of our problem says that, so we've got the bearing at 22 degrees. Now it says the slope is 30 degrees positive. So when I think of positive, I think of going this direction. Okay? That's the way I'm looking at it, okay? Is this is kind of my 0, and if I'm going positive, I'm going to go this way. If I was going to go negative, I'd be going this way. That's the way I look at it. I'm pretty sure that's correct, so we'll go from there. So that's the way I worked it, at least. So basically what I want to do is I need to draw a line. Okay. Now I don't know what angle this is on, so I need to draw a line from here over to here. Okay. Now that's not the true length, but let me show you a little trick. So if I go to rotate and I pick on this guy right here, enter, and then pick this intersection as my base point or this end point, right? Now see, I don't know what angle it is that I need to rotate. Well, yeah, I do actually. I was going to try and do something spiffy, but you know what? All I need to know is how far to rotate it, right? Well, I need to go 30 degrees in this direction, which in AutoCAD would be negative. So negative 30. Here I was going to try to be all cool, use a reference, make it look all neat. I didn't need to do that. All I need to do was draw the line parallel, on top of this one, and then rotate it from this point 30 degrees. Boom, there it is. Now, to get it to, all I have to do is extend it up to here, like so, and now I have the true length. Isn't that cool? I think so. I think that's pretty cool. Oh wait, no, I don't have the true length. Sorry. Let's back to truck time. So what that actually means is I just have this line up here and I extended it for no reason, right? Okay, well let's get rid of these two lines so we don't get confused. No need confusion. It's fun enough trying to do this stuff, right? Okay, so here's the deal. You need to have this line a certain length. They gave us a true length. So let's look back on it real quick. So we've got our bearing, we've got our slope. Slope angle there, 30 degrees, bearing 22 degrees. Now we have our true length, it's 3 inches. How do I make this line 3 inches? Well, there's this cool little command called lengthen, L-E-N, yeah, there you go, lengthen. And then you come down here and for total, I want to put in the distance that I want, which is 3, enter. And then I pick the end that I want to lengthen, like so, boom. Alright, guess what? Now that's true length. So now I can actually draw a line from here, perpendicular, right, to this. And you're saying, why would I need to do that? Well, that's how I'm going to get my rise over run. See? I need to figure out what my percent grade's going to be on this thing, right? So it says bearing, slope angle, percent grade, true length. Well, my true length is 3, right? Well, here, let's go ahead and start filling some things in. So let's go single line text. It looks like it's set up right, so I'm just going to pick a starting point, and then 0. You always want to put in 0 for your angle of rotation. So what's our bearing? 22 degrees. Remember, it's percent D. Slope angle. That one was a negative 30% D for degrees. And then our true length is 3 inches. You just say 3 inches. Alright, so now I need percent grade. Now how do we figure out percent grade? Well, percent grade is basically rise divided by run. So we're going to take 1.5 divided by 2.6, and that's going to give us 57, 69, 23, a whole big bunch of numbers, and then we're going to multiply it times 100 to get our percentage. So now it's 57.69, which I'm just going to say is 57.7. Okay? So I'm going to come back over here. I'm going to hit dtext again and pick my start, enter, because I want it to be 0. And what did I say it was? Let's go back and look. 57.7. 57.7%. Enter, enter. There it is. Alright. So, I'm going to be kind of anal here and kind of fix these because I like it a little bit neater. So, this is how you work the problem. Now you're saying, is that it? Well, no, not exactly, because I still have this dangling down here and these aren't right. So, what do I need to do? Well, the first thing I need to do is go up here, draw. I'm going to go backwards, and I am going to draw from this point perpendicular through my fold line, right? Okay, then I need to extend this line. So now that becomes the correct length in this view. Now this is true length, okay? Remember, this is true length. So it helps if you go. There we go. Alright, so true length. That's true length. Alright, that's rise. This is run. That's true length. There's your bearing. So then all I have to do is draw me a line from here, perpendicular to there. And if I had used my lovely, yeah. Anyway, well, it's fine. I'll do my extend here in a second. So this is reverse of me finding true length. Normally I would measure here to get this measurement up here. Well, I'm going backwards. This measurement from here to here, that's this distance. So that means that the distance down here to B or C or whatever point it is, that has to be this distance here. That's pretty cool, isn't it? I think so. So what I want to do is go to offset, and I want to pick, oh, you know what? I actually want to pick from the actual fold line. That would be good. So let's do that, and let's try again. So I want to go from the fold line to there, and then there it is. So now if we extend this down to here, so now I have my other point. There's my other point. I can draw a line from the center of this point here to there, and now I can erase stuff that I don't want. And so there you go. That is the way you work the problem. So what is the difference between this one over here? Well, let's quickly talk about it and see what the difference would be. It might make a little bit longer video, but you know what? Let's do this. Let's figure it out. Okay, so the second part of this says that RS is south 75 east. So south 75 east is going to be over here. So we're going to draw us a line. And you know what I'm going to do? I'm just going to draw him down like this. And I'm going to go to rotate and center. Now, it's going to rotate this direction anyway, and I need to go 75 degrees east, so I'm going to rotate it 75 like so. Okay, so this distance here, if I go back in, put in my angle like I'm supposed to, is right here. There you go. There's my bearing. I still don't know where the end of this line is yet, but I do know that if I were to copy this and then, like I said, I go up here and I use my parametric constraints and I do parallel and I pick this first, then I pick this. So now this is parallel. Now I can go over here to my ray command, right? Ray command, and go through there. I need to go perpendicular, that guy. So as long as these are perpendicular and these two are parallel, you're golden. Alright? So then all I have to do is figure out where this guy is. Alright? Offset your line this direction. Okay, so this is now point R. So I'm going to copy this up, and that's point R. Okay, so this one has a slope of -10. Now what that tells me is I need to go down from my line, because it depends on where you're starting from. So I'm starting here at this point. To me, if I was going to go up, since I'm going this direction, I know the line's going to go this direction. If I was going up, it would be on this side of the line. If I'm going down, it'd be on this side of the line. Okay? So I'm just going to draw me a line. And somehow it's going at 15 degrees. Go figure. Alright, so, well, that makes sense. It's a 75, so that works. Let's see. So the true length on this one is 4 inches, so I'm going to draw me a line that's 4 inches long. It just happens that it lined up on here. Now, I could have just drawn the line, rotated it down to 10 degrees, and then done the lengthen command again. That would have worked fine. It just happened that this one lined up on this even, 15 degrees. Okay? So now I'm going to go to rotate. I'm going to rotate this guy. And this is going to be a -10, so because it's going clockwise, so -10, and so this is at the proper angle, and it's actually the proper length too. So what does that mean? Well, let's figure this out. So this is our slope angle, right? 10 degrees. I need a line that is perpendicular to there, so that I can get my rise and run. So I need my rise, alright, and then I need my run, which is going to be from there over to here, like so. There we go. Okay. Now, I'm going to go ahead and get rid of this line because I really don't need it anymore. Well, you know what? Actually, I'm going to leave it because I could use it for something else. Nah, you know what? No, I'm going to get rid of it. Decisive. There you go. All right, so rise, overrun. So let's go find our percent grade, right? So it's 0.69 divided by 3.94 equals times 100 equals, so it's 17.5% grade. All right, so let's go ahead and put that up here, 17.5% grade. Let's see, dtext, 17.5. 17.5% grade. Cool. All right, now what was our slope angle? -10. Let's go ahead and put that on there, -10. Remember, it's percent. D as in dog. Bearing. What was our bearing? Our bearing was 75 degrees. So actually, it's south. So south, 75%, D, east. Oops. East. So that's actually our bearing. Okay. Now the fact that I didn't do that over here would kind of be wrong. So let me fix that. So over here on this one, I'm going to fix this. So it's north space 22 degrees space west. There we go. All right. And if you didn't put the space in there, it's okay. I'm not going to get that picky. All right, and true length. True length was 4, right? So we can figure that out. You can go up here, you can click on measure, you can do a distance, and you can go and 4. There we go. Okay, and then so dt for dtext, click starting point, enter, and 4 inches. All right, there we go. So that answers that question. Oh wait, we're not done. We have to project this line back through. See, we're going to forget this if we're not careful. So that's why I was going to reuse that line, but it was going to kind of be a pain, so I decided I'd just go ahead and redraw my ray. Alright, so then all I have to do is extend this line there, right? And then I can draw me another ray from here, perpendicular to there, right? And dang, now where am I going to figure out my distance? Oh yeah. So remember, like I said, normally when we're trying to find true length, you have the distance down here where the other point is, right? Well, I have it up here. It's basically this distance from here to up to here, because this is my fold line, okay? This is just a line that, you know, that's just a line that I'm keeping there to help me figure out what my you know, rise and run is, basically. I just make a little triangle out of it. Works. Okay, so I need the distance from here to here, so I'll go offset. I'll pick there, perpendicular to there, and then, alright, so there's my point. And my point being is I'm going to draw a line from that intersection to the center of this little dot over here, and there is my original line that I would have had if I'd been given it, but I wasn't. So this is one of those problem solving things where you have to work backwards, and that's okay. Alright, so I'm going to get you started on this one, and I'm going to let you finish it. And you're like, oh great, I don't get the answer. Well, you know what? I bet you can figure it out. Okay, so we'll get you started. So on the third one, if you look at the third one, it says MN, right? Now it's not this N, that's north. It says north 60 degrees east. Alright, so let's draw us a line north 60 degrees east. So if I were to draw me a line, right, from the center of this up. I don't care what the distance is. And I said it was north 60 degrees east, so that means I'm going this direction. So I'm going to go rotate, pick it, and we'll go to center again, and I need to rotate it negative 60. Alright, so now that's east, right? Correct? East. And just to make sure that we're right, I know that my bearing, there it is, 60 degrees. Okay, so to find the true length of something, you have to go parallel with one of the lines, correct? So as long as a line is parallel with a fold line, it is true length in the adjacent view. Well, it's not parallel to this fold line, so this view down here is not true length. So I have to make one. Alright, so we'll just go ahead and work this guy. Shouldn't take us too long, right? That's what he said. Okay. Like I said, I like to cheat a little bit. It's not cheating, it's just making efficient use of my time. And I like to use the grips to do some work, and there we go. Okay, so now I need to go up here to draw. I need to go to Ray and center, perpendicular. So remember, this line is always perpendicular to your fold line. Okay, and then how do I figure out where M is up here? I measure down here because this is the view I'm projecting from. I'm projecting into this one, so I come back over here to measure from this one. Alright, offset. I need to go to center, perpendicular, and I'm just typing them in. And then I'm going to offset this guy up there. Okay, so that's point M. Copy. And here's the thing. I would probably label both points just so that I had MN and RS and BC and yeah, made it look perfect. That'd be great. So am I going to count off? Well, I don't know. Turn it in and find out. How about that? So main thing is we're already here. We've got this. And it says that our slope is 15 degrees. Well, like I said before, you look at where you're at. So this will be up, and this will be down. So this will be positive, this will be negative. Alright, so I'm going 15 degrees up, so I'm going to draw a line here along this guy right here. Now it comes again that I'm actually on a line that my polar lines up with. Imagine that. Well, the distance on this line is 5. That is a long line. And it says that the slope is 15 degrees. So I'm going to take this guy that I just drew at 5, and I'm going to rotate him 15 degrees. And since I'm going positive 15 degrees, it's going to go up this way. So I actually typed in positive 15 degrees. And so now that's your angle, right? So we've got our bearing. We've got our angle. Now we need a line that goes from here perpendicular to my fold line. Okay, so that is my rise. So I need to go with my line dimension. And it doesn't matter that it doesn't touch the goofy fold line. I'm not worried about that. Okay, let's see. What do I need to do? Well, eventually I need to extend that over, I guess, but it'll be fine. Okay, so I've got that. Oh, I need to run, right? Correct. Okay, so we're going to go from there over to there. I'll pull it up here. Yes, I'm pulling it over the line, but you know, for this, I'm just trying to get some information. Okay, so this is kind of in the way, so I'll scoot it over here. So we have rise over run, so it's 1.29 divided by 4.83. and that's going to give us our rise over run gives us our slope, and then the percentage, well, we're trying to get our percent grade. So you do rise over run, and divide that out, multiply by 100. Sorry, getting tired, I guess. And we have 26.7 degrees. Okay, so that's what you want to do. So I'm going to leave this one as is. So I'm going to see if you can figure out how to get this back down there. So I'll give you a head start. What I need to do is I'm going to move that up to that where it touches it, or that intersection there. So what you need to do is you need to draw a line, or well, don't not draw a line. Well, yeah, you will draw a line because you're going to project down. So what you're going to do is you're going to draw a line from this point perpendicular to here. Then you'll do a ray going down. Okay? Now, how do you find this part down here? This distance? Well, you need to know what the distance is from this point to this fold line. So you're going to transfer that distance there, down here, and then you just offset this line that distance. Remember, all you have to do is pick here, and then perpendicular to that, and then offset this line down. Well, then draw your line, and, well, I guess you kind of have to draw a line down first. So you draw your line from here perpendicular to this, so it touches there, so that tells me where it hits the fold line. And then I come actually, no, I don't. I guess I better finish working this because you're just going to get confused, right? Yeah, probably. It's okay. It's kind of one of those days today, I think. Alright, so I need to, first of all, let's just draw a line. So I need to draw a line from here, perpendicular to here. I apologize. It's just kind of one of those days. So yeah. So why did I not just draw a, why did I not just draw a ray? I should have drawn a ray. See, I've done it 3 times. I should have just stuck with my guns and said, okay, you guys figure this one out. But no, I'm being nice, right? Alright, so the ray comes down there. That means then you can extend this line up. We'll see how many people actually watch the video and then get it done. We'll see. You never know. It might work out. Okay, so then I'll need to draw my ray from here this way going down perpendicular to my fold line. See? So we do that, and so now this point is on this line somewhere. So then I have to come back up here, use my offset command, and I need to measure from this point perpendicular to that, there, and offsetting down. You draw your line, intersection, and there's your line. Okay, so what I'm going to leave for you to do is you can fill in this information, and you can add your letters to the end so that we have M, N, M, N, M, N, and you can go back over here and do the same thing. You can put in your S's, right? Put your S's in, and then over here, you can make that a B if you want. A, B, A, B, A, B. Okay? So, a little bit longer video than I intended, but hey, it gets the job done. And hopefully you'll get this assignment and feel good about it, and we'll see you next time. Have fun.